For these last ones, I'm going to go out of order because the last two kind of looked really ugly, so I figured let's just get those two out of the way. Okay, so notice in this, we can't do anything with this group and this group because they don't have the same index. If they were both a cube root, we would be able to put everything together under the same radical together. This is where our rational exponents really come in handy. If we rewrite this with rational exponents, we'll be able to combine these x's and y's together much easier and legally. So I'm going to take that x cubed y squared, rewrite the cube root as to the 1/3 power. I'm going to take that x to the 5th. I'm going to rewrite the square root to the 1/2 power. And the y just kind of gets to hang out. So we're going to apply our properties by multiplying the exponents. So that becomes x, that becomes y to the 2/3, and that becomes x to the 5/2, all over y. No more radicals, no more restrictions. Now I'm allowed to add and subtract exponents at will. So remember, that is an exponent of 1, that is an exponent of 1. Since the x's are in the numerator themselves, we can add the exponents together, and that would give me, since that would be 2 over 2, 7/2. The y's are being subtracted, so therefore we can subtract in order, top minus bottom. Can change that 1 to 3 over 3, and that gets me y to the negative 1/3 power. No negative exponents in our final answer, so x to the 7/2 stays in the top, and the y to the 1/3 stays in the bottom, and that's as good as it's going to get, at least for right now. Okay, same idea. Can't do anything because of the fact that we have a whole bunch of different radicals, a cube root, a 4th root, and a square root. So we cannot combine anything together. Using rational exponents, though, yes, we can combine things together. So that first little guy, we'll turn him to 2 to the 5/2 power. This next one becomes x to the 2/3 power. The denominator, because 2 and x are inside the set of, or underneath the radical together, I'm going to keep them in a set of parentheses and raise both to the 1/4 power, because it's very important that I know that that 2 that happens to be in the denominator gets raised to the 1/4 power. And then x gets raised to the 1/4 power. Now you've got things that have the same base, so again we keep the base. We're going to do something to the exponents. Since we are dividing, remember that our order is to subtract the exponents, top minus bottom. 5/2 minus 1/4 is going to get me 9/4. And 2/3 minus 1/4 is going to get me 5/12. It's not real pretty, but you know what? We're going to leave it as is. Alright, so now I'm going to jump back to the first two examples, and like the other ones I've done, I'm just going to kind of keep silent and just kind of work through them.